think we can get started. Welcome everybody to the 21st panel. Who would have known when we started that we would have 21 webinars for the IIEA? Huge welcome. As you have noticed, what we are doing is we are unfortunately we could not have the conference take place in Doha. But instead, we are very, very pleased to have many of the papers that were accepted have also accepted to be presenting in the webinar series. So that's we're really, really thrilled about that. And I'm especially excited because today's topic is very close to my heart, which is on climate and development. And we have two fantastic speakers joining us. We're going to start with Fatemeh Asghari from Sharif University of Technology on rainfall, birth weight, and endogenous pregnancies. And after that, we're going to move straight into Amirhossein Amini from Howard University. Those of you who recognize the university is also the University of Kamala Harris on dust storms and house prices. And then please feel free to use the chat, not the chat, I'm sorry, the Q&A function to put your questions in while the speakers are talking. As usual, we do the Q&A at the end after both have presented. So without further ado, I'm going to hand straight over to our colleague Fatemeh. Please do share your slides, and we're very much looking forward to hearing about your fantastic work.
Hello, everyone. Thanks for joining me today. I'm Fatemeh Asghari from Sharif University of Technology. I'm a PhD candidate, and this is the first chapter of my thesis I'm going to present for you, and it's titled Rainfall, Birth Weight, and Endogenous Pregnancy. And it has been conducted under supervision of Dr. Rahmati. All right. So the outline is that we're going to talk about the motivation and why this topic is important, and then we will see our research contributions, and we will look at the data, empirical strategy, and then we will see the results and what we can infer from these results. And then I'll be happy to answer any questions you have. When we talk about what drives economic growth, we often think about capital and labor, but it's not just about the quantity of labor, but also about their health, their skills, and their economic productivity. So that's where the human capital field comes in, and people in this field often ask questions like how this human capital is formed, and when is the best time to intervene, and what is the best intervention. So they want to make sure that people are equipped to make meaningful contributions to the economy. There is this hypothesis called fetal origin hypothesis. Originally, it's a medical theory, but it has been extensively developed by economists, and it suggests that human capital formation begins from before we are even born. It begins from prenatal stage, and it suggests that each of us is born with an endowment that shapes our future health, our future skills, education, and economic potential through our life. And this endowment, unfortunately, cannot be modified or changed. And no amount of wealth or quality of education or later health interventions can compensate for poor start. So what factors can impact this endowment? Turns out that various shocks and environmental factors can impact this endowment. And among those shocks, we are going to focus on rainfall fluctuations. Rainfall may seem an odd thing at first, but when we look at it, local economies are heavily dependent on rainfall. Rainfall fluctuation translates to changes in income, workload, and even pregnancy timing in some communities. So this study investigates how prenatal shocks affect health at birth, and in particular birth weight, because birth weight is both an indicator for prenatal conditions, and also it's a good predictive index for health and economic potential in later stages of life. So what is our contribution to this field is that first we're going to use a rich data set. It is an administrative data set on uh, Iranian mothers and neonatals for 2 consecutive years, and we aim to sorry, we aim to get more accurate results using this data set. The second, our second contribution is that one issue that is often overlooked in this context is that babies are not born randomly. People decide to get pregnant or not, or if they get pregnant, they decide to go further to keep it or not. So we try to use a two-step Heckman model to correct for the selection bias to get more accurate results and unbiased results. And our third contribution is that Iran is a vast country with several climates, so our results are more applicable and generalizable to other contexts. Ultimately, we hope that our study paints a perspective for the policymakers uh, so that they make policies to support healthier and more productive lives from the beginning. So we use 5 data sets in this research. The first is Iranian mother and neonatal data, which is briefly called IMAN. The next is weather data. Next is household expenditure and income survey, labor force survey, and also we used census data to uh, address the endogeneity in this context. Uh, so our first data set is Iman data set. It's an administrative data collected at birth by Iran's Ministry of Health and Medical Education, and it has information on over 2.8 million births from March 2014 to March 2016. And it has information on maternal demographics, medical history, pregnancy risks and conditions, delivery risks and conditions, and neonatal health indicators and delivery outcomes for the mother and for the baby. Mean birth weight in this data is 3.1 kilograms with half a kilogram standard deviation. 51% of babies are born through a C-section, 48% are girls, and 6.6% are born with a low birth weight, which means that they weigh less than 2.5 kilograms. On average, mothers are 27 years old, have been pregnant 2 times, and lost 0.2 pregnancies. 20% of mothers have university degrees, 22% are married to a cousin, and 3.6% of the mothers in the sample are non-Iranians. Now we're going to look at our rainfall data, which is daily rainfall collected from 414 stations around Iran. And as we can see, this is in this map, we can see the average annual rainfall in each province of Iran, and we see that it can be as low as 100 millimeters or as nearly as high as 1,000 millimeters. Using Iman data, we have the birth date and the gestational age of each baby, so we can determine the exact or approximate conception date. Based on this conception date, we can determine the periods of each trimester. Each pregnancy is divided into 3 trimesters. The first trimester is from week 0 to week 13. The second trimester is from week 14 to week 28. And the third trimester is from week 28 until the end of pregnancy. There is a logic behind dividing the pregnancy into 3 trimesters because roughly speaking, in the first trimester, the organs begin to form and the neural system begins to form. In the second trimester, they develop, and in the third trimester, the baby gains weight. So according to this conception date, we were able to have 7 time periods, 3 trimesters, and 4 quarters before the conception date. And we calculate the aggregate rainfall that each baby has experienced in these stages. And we compare them to their 15-year historical average and standard deviation, and we define 3 stages for rainfall. The first is drought, that is more than 1 standard deviation decrease in rainfall relative to historical averages. The second is called downpour, more than 1 standard deviation increase in rainfall relative to historical averages. And this third state is a neutral state, that there's no significant fluctuation. Here we can see the percentage of babies that have experienced rainfall, downpour, or drought, and we can see that in each stage of life, around 30% of babies have experienced one of these 2 stages. The next data set we use is household budget and labor force survey. We use household budget, although it's not completely accurate, but it's prevalent to use a household budget to have some city characteristics like average income in the city, and we used it to see how cities are dependent on agricultural income, how households are dependent on agricultural income. The second data set we used is LFS, which is a labor force survey, and it's a seasonal data set on labor market variables. And we use this variable to identify 2 seasons with a peak female employment in agricultural sector over 10 years. Peak season for agricultural sector, mothers may uh, plan their pregnancies around this time, or uh, may they may lose pregnancies because of heavy workload, and the heavy workload can also impact fetal health. So based on these seasons, we divided provinces in Iran to 4 category of provinces, and it interestingly is consistent with Copenhagen climate classification. And we see that the first region is the humid subtropical region with peak season happening in summer and in spring. In the Mediterranean climate, which is colored blue, the peak season also happens in spring and in summer. The third climate is a steppe region, in which it's colored orange, in which the peak season happens in winter and in spring. And our fourth climate is arid areas where sorry, where peak season happens in fall and in spring. So we wanted to address the potential we wanted to address the sample selection. So we want data on mothers who gave birth and on mothers who did not give birth. So we use a 2% sample of census data on married women in fertility age. And we have their demographics, and we used agricultural peak seasons. We wanted to calculate the probability of a mother giving birth conditional on the drought or downpour she has experienced 4 quarters before this month, and her demographics, city characteristics, and time fixed effects. So if the sample is a weighted sample and it's represents more than 10 million married women in fertility age, and nearly 2 million gave birth in our sample. So if we compare census mothers to Iman mothers, we can see that these two samples are similar. So what is the empirical strategy we used? In the first step, we estimated a probit model to to estimate the coefficients of the probability of conceiving this month, conditional on seeing the drought or downpour 4 quarters before this month, and on mother characteristics, city characteristics, and year and month fixed effect. After estimating the coefficient, we estimate the value of this equation, and we calculate the inverse Mills ratio, which is the PDF to CDF of this equation, and include this inverse Mills ratio in our second step as another regressor. That means for a mother I living in CTJ, if for for uh, for mother I living in CTJ, if the baby is conceived at a peak season, what is the effect of drought and downpour on its birth weight? Controlling for pregnancy characteristics, mother characteristics, city characteristics, and also year and time fixed effects. We include this lambda, and this inverse Mills ratio captures the likelihood of selection into the sample, captures of the likelihood of the mother being in our sample. And with these two assumptions, we can estimate unbiased estimates for gamma and lambda in the previous equation. Epsilon and nu, the error terms must be independent of the regressors, and their joint expected value must equal 0, and the expected value of epsilon, conditional on nu, must be phi nu. This is the same phi we estimate here. And positive phi means that unobservable variables that lead to pregnancy also increase birth weight. And negative phi means that the unobservable factors that make it less likely for a mother to be in our sample leads to increase in birth weight. Since two-step Heckman model involves sequential estimation, standard errors from the second stage might be underestimated, so we use a bootstrap method to correct for standard errors. So what are the results? Results from the first step show that rainfall fluctuation matters to pregnancy timing. Among all observations, step observation and arid observations, a downpour experienced 6 to 9 months prior to peak season translates to less babies in peak season. One explanation might be that families see the weather status and they anticipate a heavier workload in the peak season. So they plan their pregnancy around this time, or they simply may lose the pregnancy. And we can't see any significant effect in the Mediterranean region. And one explanation is that agricultural sector is relatively small in this area relative to other sectors of economy. And in the humid subtropical area, we see that downpour experienced 9 to 12 months prior to peak season, maybe it's another peak season, leads to more babies. One explanation could be that the increase in income increases the probability of marriage and conception. So this is the results of our main model of the second step. One thing we can see is that the impact of drought and downpour are not symmetrical. And families seem to be more prone to downpour than to drought. This is because maybe there are mitigation strategies in Iran to protect families from drought. Uh, when in the case of drought, people can rely on underground water resources, and also there are insurance plans that protect families from income loss due to loss of agricultural output. But in the case of downpour, since agriculture is done in a traditional way in Iran, it it depends heavily on workforce. So in the case of downpour, all family members, including pregnant women, must contribute to get the job done in the proper timeline. So mothers have to work alongside other family members. In the arid areas and in the humid subtropical areas, we see two big uh, coefficients, which accounts for around 3% to 5% uh, of average birth weight. One explanation is that in the arid areas, um, the main product is saffron, and in the humid subtropical areas, one of the main products is rice. And these two products rely heavily on female labor force participation, and it's done uh, mainly by women. So, as a downpour in second trimester in these two regions results in heavier workload for mothers in during second and third trimester of pregnancy. The other thing that we can see is that selection bias exists and it's significant. Although if we compare the results from a simple OLS to Heckman, we see that our main channel, the main channel of pregnancy timing and this endogeneity is not rainfall, but there are other factors important in this case. Sorry. Factors that like number a mother has delivered and mother being having a university degree. Mothers in Iran on average have less than 2 babies. So number as a mother has delivered before plays a pivotal role in determining the decision to get pregnant or not. And one thing that is worth noticing is that if we don't account for sample selection in such studies, we may underestimate the effect of something like female education by 20%. And it may have a weaker policy implication, although it's more important than what is originally estimated. So something like mother's age may seem important at first, but as we control for the sample selection, these effects lose their significance. And as a robustness check, we also did a panel regression, and we benefit from more than 26,000 mothers that gave birth 2 times in our sample for 2 consecutive years. And we see that the results, if significant, are compatible in sign, are consistent in sign and magnitude to what we saw in Heckman model. What I learned from doing this research is that rainfall fluctuations can shape family decision to have babies, and rainfall shocks during pregnancy have measurable effect on birth weight, reinforcing the fetal origin hypothesis. These effects are different across climates. Mothers in Iran are more vulnerable to downpour than drought, and prenatal support programs in climate sensitive and in female dependent regions could mitigate negative health impacts. And the findings contribute to understanding how environmental variability influences human capital development from birth. Thank you for your attention, and I will be happy to answer any questions you have.
Thank you very much, Fatemeh. That was brilliant and perfect to the time, on the dot. And I see you've already got a few questions in the Q&A box, but let's wait with that until after Amirhossein has been taking us through on a different topic related on house prices and dust storms. Over to you, Amirhossein. Thank you, Fatemeh. Amirhossein, yeah, perfect.
Okay, hello everyone. I'd like to begin by thanking IIEA panel organizers, the host, especially Mohammed and Kamiar, and I appreciate all the attendees attending this session. I'm excited to share results of this working paper with you, and I'm looking forward for your feedbacks and thoughts. This is the title of paper, as Kamiar said, is Dust Storm and House Prices. This is a joint work with Dr. Mohammed Ahmadizadeh and Dr. Hadiya Salih Esfani. So let's start. Okay. We investigate the effect of increase in number of dust storms, or let's say exposure to dust, on housing market. This is in the literature of the effect of overall air quality on housing prices, which is of interest in both environmental economics literature and urban economics literature. In urban economics, we are interested in environmental disamenities and the effect of those amenities or disamenities on house prices. In the environmental economics literature, since there is no market for air quality or air pollution to value the air pollution or measure the cost of air pollution, using hedonic models and housing market data is a useful tool to measure, let's say, the average marginal willingness to pay of individuals for air quality and to put a value on air quality. Our results show that increase in the number of dust storms in the past 2 decades is associated with a sizable decrease in house prices. We had 2 good data sets. I mean, like one of them, the micro level data, we had access to more than 2 million housing transactions in the transaction level data set that we have all over the country. Which this is specific data that we have consists all apartment transactions in Iran from 2010 to 2017. We also utilized the city level data, which measure the average house prices for provincial capitals in Iran over a longer period of time. So dust storms are meteorological phenomena that are generated in arid areas when a strong wind lifts large amounts of dust particles from the ground high into air, carry them into long distances. Dust not only includes like lower, smaller particles, which is mostly associated with industrially induced pollution or gasoline-induced pollution. It also includes heavy elements like lead, for example, and it's very visible. When people are exposed to dust, they can easily identify it, and it has, tangible adverse impact on health. Dust storms can last anywhere from a few minutes to several days consistently, leaving again a layer of dust on the path. So there is literature on the effect of dust specifically on health outcomes, especially, and economic activities. But this is probably the first paper that look at the impact of dust storm specifically on housing market, as far as we know, anywhere. And one reason is that we had a very good data set on housing market, and the pattern of dust storm, the fluctuations, provide us this framework to somehow address the causal link between this type of pollution and housing market. Countries in MENA region are again part of what has been called dust belt. due to global climate change, human activities, policies, incidence of these dust storms has increased throughout, especially throughout the MENA region in the past couple of decades. So part of that, I mean, related to droughts, part of that is also because of long-lasting droughts. Part of that is because of political instability, especially for the case of Iran, the political instability in Syria and Iraq is one of the main sources, one of the main sources of dust storm in Iran. So as a result, I mean, this is also, I mean, many of you are familiar, especially if you are from Iran or live in Iran, you are familiar with the phenomena, especially people who are living in southwest of Iran, in Khuzestan, for example. This picture is from city of Ahvaz. It's a different type of air pollution. Yes, like it's very visible. It has immediate adverse impact. So what I mean, we were lucky in a sense. I mean, lucky in a sense of research that we had this variation. Whenever we want to look at this kind of the effect of amenities on housing prices, you want to see variation both in terms of geographic variation and like variation over time. So this figure shows, at least since 2000s, the average annual dust number, dusty days per year, showed by blue lines, is increasing. But at the same time, the red line is also showing a standard deviation of the number of dusty days per year has increased too. So not only we had increase in the level of dusty days, but the increase was heterogeneous over the country. That is how we can use this kind of heterogeneous effect to measure, to somehow measure the causal impact of dust on housing market. So if we choose selected number of cities, like here you see Ahvaz shown by blue, Kermanshah, Shiraz, Tabriz, Yasuj. These are the cities mostly in west and southwest, especially, that experience a dramatic increase in the number of dusty days per year over this time period. Other places, other cities may have also experienced some sort of increase, but not comparable to these cities on the left. So, for example, Tehran, Mashhad, Rasht, Kerman, these cities did not experience much increase in the in the frequency of dusty days in recent decades. And another interesting, important point for dust is that the source of dust storms, for Iran case at least, is mostly external. Like this is based on the literature. I mean, there's a literature on the study of the overall dust storms in Iran. For example, this graph from Bulurani et al. 2014 showed that from 2000 to 2008, the main sources of dust storms in Iran were not in the country. I mean, like our main interest would be, our main concept would be that if the source of dust is local, yes, but like if it is external, we have some sort of exogeneity here. We can be less concerned about local variables, local economic variables that may explain both changes in the level of dust and also changes in house prices. But again, the source of dust storm in Iran, mostly in Iraq, Syria, partially again because of long-lasting droughts, partially because of political instability, and like in Saudi Arabia. So we have this increase in dust, the impact is heterogeneous, and the source, according to literature, is external. That's a perfect framework for measuring the impact of air quality, this type of air pollution on housing market. Generally, the studies on impact of air quality on house prices are like as old as Ritker and Henning, for example, 1967. Most earlier studies were correlation studies. Recent studies, relatively recent study, Chai and Greenstone 2005, Granger 2012, and my other paper 2021, we like in this literature try to address the causal relationships, somehow finding a framework, whether it is IV, whether it is like fixed effect models, to find a framework to show that the relationship is not just a correlation, but a causal relationship. Um, but also there's literature on dust storms. There are important historical cases of dust storms. The probably most known one in the United States is the Dust Bowl, 1930s area. There are a number of papers on the effect of Dust Bowl. Hornbeck 2012, for example, shows that this phenomenon has persistent negative effects on agricultural activities, has led to persistent relative decline in agricultural land values in more eroded countries in the US. There are a number of other studies in the literature that looking specifically at this type of dust storm, like Jones 2022, 2023. There is also this other working paper of Dr. Birjandi and Dr. Yousefi, which look at Iranian dust storm and its impact on industrial activities. They show that the higher exposure to dust storms reduces productivity of industrial firms, which is, like intuitive in a sense that dust has a significant negative effect on daily performances, like daily economic activities. There are a number of studies on the Middle East. Other studies on the Middle East, mostly showing again correlation, mostly look at the effect of dust storm on again child mortality, health outcomes. But again, this study is probably the first one to utilize a hedonic model and housing market to somehow measure the average marginal willingness to pay of individuals for air quality. We got our data, the weather data is from MIDAS, Met Office Integrated Data Archive System, British Atmospheric Data Center. I'm going to explain about the data. We got our transaction level data from 2010 to 2017 from the version of data that we got was from Iran's Ministry of Transportation and Urban Development. I know that they provided this data also online for some period of time. I'm not sure it is still accessible online. Statistical Center from a Statistical Center of Iran and Central Bank, we've got provincial capitals data on house prices and CPI variable. The MIDAS data covers 86 ground stations in Iranian, among Iranian cities. All stations report weather codes. One of the weather code, which is relevant, refers to widespread dust suspended in air, not raised by wind at or near the station at the time of observation, code 6. So this is a code also that Birjandi and Yousefi paper used. It seems that this is also a code that, at least in Iran, according to the interviews that a study has done, is the main code that reflects dust storms or incidents of dusty days in Iran. We classify a day as a dusty day if the ground station reports at least one occurrence of weather station code 06. The frequency is every 3 hours. We have reading for this code, and if in a day we have one occurrence of code 06, we consider that day as a dusty day. We then calculate the share of dusty days STD variable for given period based on the data that we are using. So this is the distribution of stations in Iran. As we see, we have stations probably cover most areas in Iran. Overall, the match data set includes in the transaction level data, we could match 1,800,000 housing transactions across 66 cities. Some of these stations were in like outside of the cities, or like in cities with a very low population, or in islands in Persian Gulf. So they were not matched. On the transaction level data, Iran's Ministry of Transportation and Urban Development, I mean, overall, we have collection of housing market data since 2010. The government mandate requiring all housing transactions, including purchase and rentals, to be registered online. I mean, it is mandatory, but we can see that in a smaller towns, probably there is like a little bit bias. Like you have, especially when you look at the rental data. This I face in my other research, that in the rental data, the quality of data kind of fall when we go to a smaller towns. But overall, it covers transactions in almost all the cities of this study, and it provides a good index for house prices in each city. And again, since it is from 2010, and we know that the increase in the level of dust, we saw that it started in 2000s. We needed some kind of data set that cover a longer span of time. We couldn't have ideally we would want to have the transaction level data back in 2000s and or 1990s. It was not available, but we had city level estimates of house prices provided by Statistical Center of Iran from 1993 to 2016. We used the trim version of this city level data as well, because in 1990s, many cities had missing data. So in order to avoid the bias, we trimmed the city level data set with 25 cities over 17 years of data from 2000 to 2016, and run part of our analysis based on that data. Again, you can see the match data is almost 1,800 transaction level observations, and city level, the untrimmed one 1,000 and trimmed one 800. Relatively like showing that we did our best to cover geographically and time span of the study. So I start with the transaction model, transaction level model. We have a fixed effect model here. We control STD is the share of dusty days in the certain number of months preceding the transaction date. We had the transaction date data. We could calculate, for example, the number of dusty days, the share of dusty days 1 month, 3 months, 6 months, or 1 year before the time of housing transaction. We have price is here is an adjusted price per square meter for apartment J, transaction city I, date T. We could control characteristics in this data set. We had age and size, at least clean data on age and size of the unit. We control for city fixed effects, year fixed effects, seasonal fixed effect, and also a more, a stronger control variable of city specific trends, like city fixed effects time trends, which somehow capture if there is any trend, a specific trend in prices in a given city. Inclusion of this control variable is also very important, showing that how robust our result is. On the city level data, we started with the OLS similar specification. The data was based on half year indices. So we have all this time and location fixed effects, and here we use the lag share of dusty days during the half year just before period T of the price index that we have. So equation one assumes, again, this is a smaller sample. There may, this is a panel data, there may be issues arising. So we made some modification to this model as well. We run this OLS regression fixed effect model, but also equation one, for example, assumes that error terms are not autocorrelated, and that the full effect of STD in each period on house prices has materialized in the following period. Again, Woolridge test of autocorrelation reject that. To address this problem, we introduced the lag values of dependent variable. We added this error correction term to the model. So this equation two is the error correction model of equation one. And also, this when we add this error correction term, we can somehow have a revised linear estimation of the model. So this alpha hat that we are interested, the effect of share of dusty days, can be estimated by linear estimation of alpha prime hat divided by beta hat. Again, one additional robustness check, or model revision that we did, is that even including the error correction term, this equation equation 2 with or less than a standard panel method may solve autocorrelation problem, but in short panels like ours, we may encounter a dynamic panel bias, or if there is a concern that although our dust data is based on this weather code, which is the dust that is not local. It shows that the dust that its source is outside of the studied geographic area, but it may not be still fully exogenous. So we need some kind of instrumenting. This system GMM method or a nanobond method can provide this opportunity for us to instrument these variables. So in this method, we combine equation and first difference transform system GMM to address the endogeneity and inefficiency issues in short panel. Again, we use GMM style instruments, specifically second and third lags of price and also share of dusty days. Overall, like if we start with the city level data, even a simple OLS shows that there is a negative significant at the level of 5%. If we just look at all the data, untrimmed city level data. So this result is from the city level data. Error correction model resulting negative but insignificant result, but the system GMM method shows again significant like a negative effect of dust storm on housing prices at the city level data. If you use the trimmed version of the data, because of all the issues of the unbalanced panel that probably we have, the result is like even stronger, like OLS is minus 0.3, minus 0.4 for error correction method model, and for the system GMM model, minus 0.536, significant at the level of 1%. This result, especially the last column result, is close to what we got in the transaction level data when we studied all these about 2 million transactions from 2010 to 2017. So here we had not only we look at the level of dust 12 months before the time of transaction, but we divide the time period before the time of transaction to like 1 month, 3 months, 3 to 6 months. And we showed that, if you look at the coefficients, as we get closer to the time of transaction overall, the effect is stronger, which is again intuitive. Like if there is incidence of dust storm, individuals in the housing market may consider that as like some form of environmental disamenity. And based on all these assumptions that we have in urban economic modeling, these disamenities will reflect through marginal willingness to pay off individuals for avoiding these kind of disamenities in housing prices. So, like the sum of these effects of all these columns, the sum of STD effects, is close to what we got in the city level data. Overall, we can say the average long run effect across data sets methods was alpha in the equation 2 model minus 0.51, which means an increase of 1 dusty day annually lowers the house prices in economic term by 0.14%. If we have 8-day increase, which is the average of national increase from 1990s to 2000s, from 1990s to 2000 to 2007, that means 1.1% decline in house prices. Additional 19-day, when we move from 2000 to 2007 to 2016, means the further decline of 2.7%, additional decline of 2.7%, and total decline of 3.8%. So 3.8% based on the average marginal willingness to pay of individuals for air quality. Again, impact is not uniform across the cities. If we have this if we accept this is the average marginal willingness to pay of individuals, we can say, for example, a city like Ahvaz, Ilam, Khorramabad that experience higher level of increase in the level of dusty days. That means like 7 to 66, 63 days per year. That means decline of 10%, 9%, 8% respectively. In other words, incidence of dust storm increase in a city like Ahvaz during these decades, the value is equivalent of 10% or is has causally negative impact of 10% decline in the average house prices in Ahvaz. So I mean, like the percentages are also similar, somehow comparable to what we get in overall pollution impact on house prices, industrial pollution impact on house prices, or gasoline-induced pollution impact on house prices, something between 1 to 10%. So based on the framework and the data that we had, this is the first paper to gauge the causal impact of dust storms, specifically dust storms, on housing market, highlighting the environmental degradation in MENA region. Again, this is a hedonic model, probably the first hedonic model looking at dust storms, at least in the context of developing countries. The unique data set, the regional variation that we had was unique features of this study. It has important policy relevance. Again, dust storm is a global, is induced by a global issue. So it addresses economic consequences of like dust storm, emphasizing the need for international cooperation versus like some type of pollution that is mostly induced locally. This is more like a global environmental degradation issue. Future direction for further research, we can look at the broader impact of dust storms, like on health outcome, for example, providing the proper data set, especially for researchers in Iran. If they have access to health data, they can look at the impact of this dust storm on health outcomes. Okay, so thank you.
Thank you very much, both of you. Thank you so much. Over to our Q&A, and I think what we can do is please keep putting your questions in the Q&A box. There's already a couple in there. Fatemeh, I don't know if you want to take the first one, which is from Babak, which says, given the correlation between rainfall and air pollution and the well-documented adverse effects of air pollution on birth outcomes in the literature, to what extent do you think you have identified the effect of air pollution instead? Loaded question. Or how do you control for factors related to air pollution?
Okay, may I answer to this one?
Absolutely.
You make a good point, Mr. Jahanshahi, but if I have separated drought from downpour, and if I was estimating effect of air pollution instead of rainfall, so I would have had bigger estimates for the case of drought, not the case of downpour. So I don't think that I'm estimating the impact of air quality. However, I was aware that these two variables are connected, and they are often connected, but in the research in this field, we always focus on one thing. You can ask the same thing from Dr. Behbahani and ask him that why didn't you control for rainfall fluctuations? Because these two are correlated. And that's what we do. I think these two answers, that if I was controlling, if I was estimating the effect of air pollution, I would have had greater estimates for drought than downpour. And also, you could ask the same question in each climate research. So I think that's to my knowledge, it's correct to do such thing.
Okay, thank you very much. I think Amirhossein, you also got the question asked to you now. Why didn't you use the?
Okay, so like overall, I mean, the problem of this omitted variable bias, um, not only rainfall, and like for the case of for my study, drought, rainfall, all these other air quality measures. Once you have a proper framework, you should be concerned about a variable that you have not controlled that somehow mimic the pattern of the variable of your variable of a study. Yes, if we have something that has the pattern of dust storms in my studies, so like it increases, like for example in Ahvaz, or decreases in Ahvaz, but it's not the case in East. So in that case, yes, definitely you should control. Overall, I mean, like maybe referees ask actually to control for some other air quality measures, as we control, for example, for housing prices. Sorry, for housing characteristics. So again, it is a concern. Omitted variable is a concern when it mimics the pattern of your studied variable. Or like, I mean, um, again, there's the problem of endogeneity. Yes, like this error terms of your model is related to that omitted variable in your model. But yes, like it is possible to control, but based on the framework and the story that you have, if you believe that no other variable, you control for good enough number of control variables and no other variable mimic the pattern of the variable that you study, then it should not be a major concern. I'm sure that if the model is designed properly, adding these type of controls probably will not change the result, like both for Fatemeh's paper and like my paper.
Brilliant, thank you. Mohammed, you have your hand up, so you can go, and then we're going to come to the other questions in the Q&A. Or are you giving us a high five?
Yeah. No. Well, Amirhossein, you mentioned this omitted variable, and when we write about housing prices and drivers of that, so your focus, I understand, is on sandstorm and these climatic factor, but don't you think there are also some important local macroeconomic drivers, regional growth, the situation in job market, even some family behavior, divorce and marriage? I had a paper with another colleague on determinants and the relationship between divorce and marriage and housing price at Iranian provinces. And there are many other factors which at the same time could be important and could not follow the pattern of sandstorm. I saw that you have control for this fixed effect, but there might be also factors which are not necessarily fixed that are changing over time. And given the fact that you do emphasize on the identification of causal effect, I would like to know your opinion, how much these kind of other omitted variables might undermine this causality interpretation in your analysis. This is the first point. And the second thing was, what do you think about the possible mechanism through which this sandstorm might affect housing prices? Maybe something like out migration, the intercity migration as a result of these climatic factors result to changes in demand and supply for the housing, and that could explain part of your as a kind of mechanism. Do your study also focus on mechanism, or you just basically first show the overall effect? And that would be also interesting to explore. Thank you.
Two very good questions, suggestions. For the we can control for if we have a measure of income or unemployment, like any economic macro variable. It's possible to control for that in both data sets that we have, like city level or transaction level. What we have now is that we control for city-specific trends, because part of your concern was that what if a city, in terms of economic trend, like following a specific trend, or the housing prices are following a specific trend. So the presence of city-specific time trend probably partially capture that. But again, yes, macro variables can be controlled, can be added as additional control. The other one, like about, I guess you asked about mechanisms. Yes, Mohammed? Like maybe migration. Yes,
Yes,
actually,
yes, mechanism.
we have the data on migration, and we want, like, the initial draft of this paper was looking both at the migration and housing prices. We were thinking at the time to have two different paper. I mean, we didn't continue the analysis because the result of the impact on net migration, based on the data that we had, was not that robust. Like, but partially it can be because of these fluctuation in prices. It can be because of migration. The general assumption in this type of hedonic model studies is that there's a equilibrium price, realized equilibrium price, supply and demand, both sides. And that kind of pollution, or any kind of amenities or disamenities, uh, is going to be capitalized in the price, in the housing prices. Yes. So overall mechanism is that this is the subjective, let's say, measure of individuals when they want to purchase a product. If I want to buy a house in a polluted city, I'm gonna pay less, even if they don't have the chance maybe to migrate, yes, from the city. Still, this is the product that I pay lower amount of money for the because there is lower quality is associated with it. But again, yes, it's good. It's very interesting to look at also the migration, net migration, migration from rural areas to cities that are affected by dust storm, out migration from the cities that are affected by dust storms to cities that are less polluted. I mean, good suggestion. Probably we're gonna do that in a future study, or like extension of this study.
I just at the point here, I have a paper on this particular matter on intercity migration in empirical economics with some colleagues, and that came in my mind. If something like this could be basically explain this effect that you show on the housing prices, right? So maybe you identify other factors as well, but just as a hint, it could make this study more interesting in a way to understand better how it's. Thank you.
Brilliant. Thanks very much. I'm going to jump to another question. This one from Noderejun to Fatemeh. Is there a difference between the outcome for mothers with or without higher education? In other words, can more educated mothers mediate better through nutrition, etc.? Could you elaborate on that if you had already?
I have done it, but I know that they act different, and they can prevent the bad outcomes from happening. But I am not sure, because I done it last year. I'm not sure about the size of the effect. But yes, the behavior of educated mother and uneducated mothers are different.
So, but you don't know the size of, sorry, you didn't know
No,
what the
I
size
just
of effect
can't.
was. Okay. So that
No,
will be
I
interesting
just
to
can't
follow up.
remember it.
Yeah.
Yes.
Brilliant.
Yes.
Brilliant. I think it will be interesting to follow up, and maybe also connect with Noderejun. Perhaps it would be interesting to know. Excellent. Can I ask, maybe I ask a question for both of you, and then I come to the next one. Is if I'm thinking as somebody who can do anything about both of these issues, big if, what is it that you would suggest? So what would be the thing the policymaker would take away from this? We can start maybe with Amirhossein and then go to Fatemeh. What would you change?
I mean, like, for the incidence of dust storm, the issue is like regional, global. Yes, like part of that is global climate change, but part of that is the instability in Iraq and Syria specifically, that somehow, based on the literature, is one of the main sources of dust storm. So it needs regional cooperation. Yes, like if it is not local, like changing policies that only affect local outcome will not solve the problem. I mean, if the issues, whatever is political or anything else, is solved in Syria and Iraq, probably the level of dust storms are going to decrease dramatically in Iran. So that's for dust storm.
Okay, so both regional and global cooperation, an easy task. What about you, Fatemeh? What would be the one thing you will take away from your study?
I think we lack the policies that support pregnant women, and in the case of downpour, as we see that the wages go high, so family members all have to work to make the ends meet. So if some kind of if I'm going to think about some kind of intervention, maybe some insurance or some cash transfers could be helpful to stop women from working, stop pregnant women from working during sensitive stages of life.
Brilliant, thank you very much. And I'm going to turn over to some of the data questions in terms of the your paper, Amirhossein, I think is on the dust storm. There are a couple of questions in the Q&A box. The availability of the data, in particular, how do you construct the dust storm data, and yeah, anything else you need to consider in terms of robustness of the outcomes? Perhaps is there something that we missed? I think the question is asking.
I mean, like for again, the dust data is from this MIDAS data set. I mean, like there are other sources that cover this station level data in Iran. So there are like weather stations that report multiple codes for all these different elements of air quality, from, I mean, pollution, dust, rainfall. So a station level data is utilized here. We construct the level of dusty days, STD, as the share of dusty days in a given period. And for each day, it gets the value of 1 if the station reported at least one incidence of a specific code on dust, code 06, which is the external dust. If we also include one other code like 07, which is dust related code, but the kind of dust that is induced locally, I mean, lots of missing observations there. But again, our results are relatively robust to that. So that's, I mean, it's available. Like I mean, it's not that difficult to get that data. The difficult part to get was any data that is related to Iran, like the housing data. I know that at the time for my other paper, it was not shared. I had so much difficulty to get the housing data. Then we got this national apartment data. Again, at the time that Mohammed Ahmadizadeh got the data, it was not shared online. But later I heard that they made it accessible, the housing data. I don't know now, because I live in the USA. I don't have probably access to most of portals in Iran. Okay, did I answer everything?
Brilliant. No, I think that's brilliant. If anybody has any questions, as I said, please do feel free to put your hands up or put it in the Q&A box. There is another question on Iran's commitment to the United Nations framework on climate change. I don't know if any of you guys want to take that. So what is Iran's commitments, or is I suppose that's the question.
I mean, like, that's the overall, I mean, on the global level of cooperation, that's the, I mean, overall impact, like global climate change, like reducing this overall carbon emission, for example, can have global effect. And when we look at the negative impact of climate change, like one example, dust storm. And mostly countries in MENA region are exposed to that. But those kind of commitment probably will not mitigate problems like dust storms immediately, as we discussed. It's more like a regional political instability issue. But also there is a significant, I think, resistance in Iran, if I'm correct, because again, major producer of oil and gas. Maybe, I don't know if the Paris Agreement is ratified. I don't think it's ratified yet in Iranian parliament.
I think even before Paris, Iran committed to reduce emissions by 4, 5, 6%. I can't quite remember, voluntarily, anyways. But I don't know what the latest statistics are.
Yeah, like I mean, like there may be some kind of resistance by countries, like I mean Russia, for example, like or Iran, that they basically enjoy from this usage of fossil fuels, carbon emitting, let's say, methods of production. I mean, that's probably my, I don't know, my view maybe.
Yeah.
But, so, but overall, like, yeah, global cooperation can mitigate overall the overall impact, but maybe some of these issues like dust storm here, it's more, it requires more regional cooperation.
Yeah. And in fact, to address climate change, we need both. That's I think that's absolutely correct. There's another question from you, actually on the effect of housing prices. Is the question from another journalist? Is it permanent or is it temporal? And if it's and if so, how long is the effect?
I mean, like in terms of increasing the level of dust storm, as long as the sources are there, like if you look at the data, if I mean, the graph that I shared, yes, there is an increase and it's somehow persistent over time. But this is also a very good question. What if it is persistent for a long period of time, there may be this concern that people who are in polluted areas or in affected areas develop some kind of adaptation with that. Yes, like maybe their distaste for higher level of pollution is going to be lower compared to the distaste of citizens in a clean city. Like in all of the pollution studies, you have this kind of sorting problem. Yes, people that have lower distaste for pollution tend to live in the areas that are polluted. At least for this time period of a study, based on what we see, the increase in the level of dust storm is significant, even in the Western areas that had the experience of dust storm. Yes, if that is the case, there is less time for adaptation probably, and we are less concerned about the sorting problem. But if this continues over many years, maybe that can result in a bias, and then we need some sort of different type of model specification to address the sorting problem. But very good question, because sorting problem can be an issue to study the effect of pollution on housing market.
Yeah, and I suppose the other point is it's much wider than house prices, right? So there might be other spillover effects that is not captured. So some people have been working on firm level and profitability data. There's probably some impacts on the aggregate economy that also could filter down.
I mean, very good point. Right? That's a very good point. Yes, of course. I mean, there's this other study that I mentioned, years and recently looking at productivity. Yes, here we are looking at the housing market, but housing market has this interesting feature. Like in hedonic model in housing market, you basically measure individuals' willingness to pay for air quality.
Yeah.
And that somehow include, if there's a negative, for example, health impact, that should be internalized in the decision of people that how much they want to pay for air quality, better air quality. So yes, it's one study on the impact of pollution on housing market, but hedonic models like that tend to capture the value, the price of air quality. Yes. So in a sense, maybe all of these factors, productivity, health outcomes, is going to be realized. That's the assumption of hedonic models. It's going to be realized in the form of how much you are willing to pay for housing.
Fantastic. Brilliant. I don't see, there's some questions on whether we should be doing more regional studies across. And I think, yeah, that's an interesting point. learnings from other countries and potentially spillover and spillback effects of the shocks. That's a super interesting study. That's perhaps something we can look into. Brilliant. I think most of the questions now have been answered, unless there's anything else coming in. I just want to thank you so much for a brilliant, insightful discussion. And all it remains for me to do is to thank you. Big thanks to Mohammed for pushing us through and coordinating and organizing. Thank you to the speakers. Thank you, Fatemeh, for joining, and Amirhossein from joining, one early, one late in the day. And thank you to all of you who dial in as usual. Our next webinar is happening on the 11th of December, and we're chaired by Nader, who's on the call actually, and with colleagues from the World Bank and Virginia Tech, Ebad and Javad, who will be talking about their work. Again, this is work that was submitted to the IIEA conference, which we are showcasing in a webinar series over the next few months. So thank you all. Huge thanks. I've certainly learned a lot, and I'm going to go back and think about some of these issues and hope to engage in the future. Thank you.
Thank you. Thank you very much, everyone.
Bye bye.
Thank you.
Thanks a lot. Bye.